Thank you for the kind introduction. And good afternoon, everyone. Happy to be here as part of Sketchbook Earth, our project that includes my colleague Nikos and myself, Niklas. And before we dive into the topic, I'd like to draw your attention quickly to this beautiful visualization. I think I really like it. I think it's very impressive, regardless of whether or not you are familiar with climate science. And when I first saw this beautiful visualization, I could not resist trying to understand what was going on there. So I went to the website of NASA's Scientific Visualization Studio, the creator of this animation, to find out. But yeah, I don't want to ruin your curiosity, so I invite you to have a look for yourself. But the key message that I want to transmit here is that climate science communication, and specifically climate science visualization, is an important tool we need in our future path to combat climate change. And indeed, climate change communication matters. So here, as a recent study analyzed how much people know actually about climate change in different countries. And you can see here in red, like where people know more, and in blue, where people know less. And I think it's not too bold to state that the pattern of knowledge about climate change pretty much coincides with wealthy nations, where climate change communication is already an integral part. There's lots of funding available for driving efficient communication campaigns and so on and so forth. Well, even though these well-informed nations may not necessarily be more active when it comes to real climate action, but anyways. And if we now zoom into Europe, I think the Copernicus Climate Change Service, in short C3S, is a prime example of climate change communication. So I think you've probably come across their work at some point, but just in case, here's a quick overview of their climate intelligence reports. And I think what's probably the most well-known service are these climate bulletins, where they present every month the climate conditions around the world. And in addition, they also provide on an annual basis the European State of the Climate, short ESOTOC, the long-term evolutions of certain climate indicators, and also annual global climate highlights, where they really go into specific events like heat waves, floodings, and so on and so forth. So let's take a brief look at the climate bulletin from June 2023, so previous month, which depicts the global surface air temperature anomaly. And now I would like to take a step back briefly and just think about for a moment who benefits actually from these information. So who is like on the receiver's end of that information? And actually, here introducing the target audience, it's quite large. So it encompasses a broad spectrum ranging from climate scientists here on the left-hand side, educators and students, journalists and media professionals, environmental consultants who ultimately will inform policymakers and also general public, so like hobby scientists. And to illustrate here, let's consider briefly like the journalist reporting, or let's consider a journalist who wants to report on the recent heat waves in North America. And while the climate bulletin is informative, the information is only available as a static figure. So if he now wants to make a story about the temperatures over North America, he basically faces the issue of reproducibility and transparency. So how can he reproduce these images? What are the steps, really step-by-step necessary? What is the pre-processing? So it's not really clear, not really transparent. And this is where our project comes in. So our goal is to provide open solutions to reproduce these figures. For that, we only use open data sources like Climate Data Store, Atmosphere Data Store, Marine Data Store. We rely on open infrastructure like Jupyter Notebooks and Google Colab, and open software, specifically here for us Python, and very well-known Python packages like Xarray, Matplotlib, Cartopy. And secondly, we also aim to be transparent by providing tutorials that guide the users on step-by-step really how to access the data, how to pre-process the data, and finally how to visualize the data. And here on the right-hand side, you can see one of our first results. So this is a tutorial dealing with the greenhouse gas concentration evolution over the last 20 years. And our goal is, throughout these notebooks, to strike a balance between simplicity and flexibility. So we want to make them as user-friendly as possible, but at the same time adaptable so that people can modify them to their specific needs. So that means you will find throughout the tutorials individual cells that allow the user, for example, to define his or her region of interest, or to define the climate reference period that she or he wants to use. So to briefly give you an idea of how the results look like, you can see here on the left-hand side the greenhouse gas concentration of methane and its evolution as shown in the original C3S intelligence reports. And on the right-hand side, you see the result of our reproduction. So you probably note already that the style is different, but we have decided to use a Matplotlib style sheet that streamlines our visualization so that the output of all the visualization is very similar. But the underlying data is the same. So as for our future steps, we are currently working on a series of these example notebooks. Our first one dealing with greenhouse gases is under final review, and 3 more on temperature, sea ice, and sea level are in progress. And we also plan to provide 2 more notebooks about hydrological variables and river runoff. And then in the second step, we're also working on creating animations of selected variables, because we believe this is always they play like a significant role in climate science communication. So here's a sneak peek of an animation we've developed. And finally, we will also deliver a notebook on how to derive large-scale patterns like ENSO and NAO. Yes, and if you're interested by our work, or you have feedback because you are by chance the journalist from North America, then please reach out, get in contact with us, and explain us also your needs. You can follow our progress here on our dedicated GitHub repository. And that's it. So thank you. And I hope to see you in person in September.
Thank you. Thank you very much, Niklas. It's very interesting and also very, very useful for all type of audience, for training as well, or tutorials. And do you have something in mind when you finish this project? So maybe a follow-up, or you have some...
To be honest, we have not, Niklas and I, we have not really talked about it. So since it's still like a bit to go with the project, we will discuss this with our mentors. Yeah.
Good luck. Very, very well done. I don't know if someone... Oh, there's a question. Maybe I missed something, but how can CO2 sources and sink be established? Maybe from data provided by countries or industries? I don't know if this question is related to this.
Oh, yeah.
Yes?
I mean, at that point, I actually, to don't tell you any nonsense, I would really invite you to check out the creators of this animation. So if you just Google NASA Scientific Visualization Studio, will directly fall onto this. And you can then check out the underlying publication, which they have used for creating this animation.
Thank you very much.